In this lesson, you're going to learn to do 5 things here. Number 1, we're going to learn the difference between discretionary and essential expenses, determine the mean, median, and mode of a data set. We're going to use sigma notation to represent and determine the mean of a data set. So we're going to learn about sigma notation. We're also going to create and interpret a frequency distribution table. And then number 5, we're going to determine the mean, median, mode of a data set presented in a frequency distribution table. All right, so we got quite a bit to cover, so let's go ahead and get started. All right, so the first question is, what expenses do you foresee incurring once you are done with school? Okay, so probably if you decide to go off on your own, either after high school or after college, one of the biggest expenses you're going to incur is rent. Okay, that's one of the biggest expenses. And then at some point, you're going to hopefully afford to buy a house, and then you'll have a mortgage that you're going to be responsible for. Along with rent and or mortgage, you're going to have what's called utilities. And these are expenses related to electricity, water, trash removal, gas, and so forth. Okay. Other expenses might be, for example, car payment, clothing, especially when you're getting a new job, food, so we're going to say groceries. Okay, and we have entertainment, because we can't be working all the time and we probably want to go out and enjoy things in life. There's also dining expense. You may want to go out and eat. And then you'll incur expenses like gifts, right? So you're going to go to weddings and birthday parties and so on and so forth. Okay, so what I've listed is 1, 2, 3, 4, 5, 6, 7, 8 expenses. Now, this is not comprehensive, but what I wanted to do is go down this list and explain what is the difference between essential and discretionary expense, okay? So, discretionary versus essential. All right. Now, essential expenses are expenses that you absolutely need, right? Expenses you need to spend that kind of money to be able to, quote unquote, survive or live day to day. And then discretionary expenses are expenses that are nice to have. You don't really need them, but it is a nice to have. So let's take a look at the first one. Okay, we've got rent and mortgage. All right, so we definitely need to pay for something to live in, and so we would call that discretionary. Okay, so we're going to call this discretionary. The other expense that you're going to also incur are utilities, and these are, again, electricity, water, trash removal, gas, and so forth. And I would say that this is also considered discretionary because we do need to have those expenses. Okay. Now, the next one, car payment. Now, this is debatable. Okay. Most people will say, well, I definitely need to have a car payment in order to get to work. But some would also argue that you don't need, quote unquote, need to incur this kind of debt in order to get to work. There are other ways to get to work. You can walk to work. You can ride a bicycle to work. You can take public transportation like a bus or train if they're available. So there are alternative ways. You can carpool to work with somebody you know. Okay, so there are alternative ways to get to work. So we're going to call this discretionary. All right. Now, I did notice I made a mistake here. These are actually essential expenses, so my apologies. Essential expenses. Okay, now clothing, we would say that this is essential as well because you're going to need to wear clothes. Although this will not be on a monthly basis, this is probably a one-time expense. Nonetheless, it would be essential. Okay, groceries. We need food to survive, so this is considered essential. Entertainment would be considered discretionary. Although we would like to go out and have fun, we don't necessarily need to spend money to go out and have fun, right? We can go out to the park, we can go on a hike, on a walk. There are different things that we can partake that are free, go to a free museum, that sort of thing. All right, now dining, although we do need to eat, okay, we don't have to go to a restaurant to go out to eat. So we're going to call this discretionary. And then last but not least, gifts, okay? We obviously want to give gifts to people that we care about. However, it is not critical to our survival, so we're going to call this discretionary, okay? So of these 8, half of them were essential, the other half were discretionary. Hopefully by going through this list, you now have a much better understanding and flavor for what is essential versus what is discretionary. Okay, so let's move on to our definition. An essential expense is an expense that cannot be eliminated from your day-to-day life, okay? The key phrase being cannot be eliminated. For a lot of people, this definition may vary. You know, for certain people, they'll say, oh, I can't eliminate the need to go out and dine because that's essential for their daily lives. But if you're not making enough money, or if you're in debt and you're upside down, this is one of those things that you can cut out. So we would say that an essential expense is something that cannot be eliminated. And then discretionary expense are costs for goods or services that are non-essential, okay? Non-essential. 2 other terms that will come up later on, not necessarily in this lesson, but in other financial areas, are gross income and disposable income. So when we use the term gross income, this is income before taxes are taken out or deducted. And then disposable income, this is money that you have available to spend after taxes. Okay, so those are the difference. Gross is before taxes, disposable is after taxes. So let's go ahead and move on to a few more definitions here, okay? So notice that wise consumers know how to balance between discretionary and essential expenses, and they learn to live within their means, okay? More and more these days, a lot of Americans do not know how to live within their means, and they get themselves into a significant amount of debt and in a situation that causes significant financial stress. Now, in order to know how to live within your means, one of the things that we as consumers use is statistics, right? This is a branch of math that involves collecting, organizing, and studying, interpreting, and analyzing, and reporting data. So this is understanding how your expenses flow in and out of your personal life. Facts that can be analyzed to obtain more information about a situation are defined as data. Okay, so this is important pieces of information about your finances. And then here are 3 statistical terms that we are going to use in this lesson. Number 1 is the mean. We also know the term average, and average and mean are synonymous, meaning they are the same. So the typical value, so the definition for mean is the typical value of a set of scores determined by finding the sum of the scores divided by the number of scores, okay? And then the second term is the median. Okay, the median is a little different in that we are looking at the middle score of a set of scores. Okay, it's the middle term. And then the mode is the score that, or the data that occurs most frequently. So we're going to look at a couple examples to help flesh out what a mean is versus a median versus a mode. Okay, so let's go ahead and move on to example 1. So in this example, Elena knows that her morning cup of coffee is most definitely a discretionary expense. Okay, you don't have to go out and get coffee. You can certainly make your own and save a lot more money. So Elena pays $2.75 for a little 9-ounce cup coffee and was wondering if that is a typical price. Okay, so on Monday, she asked 6 of her coworkers what they paid for a 9-ounce cup of coffee. Their costs per cup were $2.85, $2.15, $1.95, $3, $2.05, and $2.40. Okay, so the question here is, how can Elena compare her expense with those of her workers? Okay, so one of the first things that we could do is find the average cost and see how the average cost compares to what she pays for. Okay, so we're going to take $2.85, we're going to add $2.15, and we're going to add $1.95, add $3, $2.05, and $2.40, and we're going to divide this by the number of costs, right? So we have 1, 2, 3, 4, 5, 6. So we're going to divide all of this by 6, and when we do, we get $2.40. That ends up becoming our average, okay? So as you can see, Elena, who pays $2.75, is probably paying more than she needs to, because on average, her colleagues are paying $2.40. So she's obviously paying for a cup of coffee from someplace that is a little bit more on the expensive side, okay? So this is how we can compare our expenses versus others. So let's go ahead and move on to the next example. Actually, before we go on to the next example, we want to cover sigma notation. Okay, so this is going to come, we're going to see this more often in some of our problems. And it's important to understand what a sigma notation is. Okay, so number 1, you see this big Greek symbol. This is called a sigma, and this represents a sum, right? We're going to be adding numbers together. This symbol right here, this X with the bar on top, is really representing the average, right? So this bar means it's an average number. And let's take a look at this 1 over n sub I. 1 over n sub I. This n sub I really represents the number of terms, okay? The number of terms that we're going to be adding. And then I equals 1 means that we're going to look at the first term, or start with the first term, and we're going to go all the way out to the nth term. So if there, in the previous example, if there are 6 terms, we're going to start with the first term, and we're going to go out to the 6th term. And then x sub I will be the sum of each term. Okay, so in the previous example, I think we had 285 and 215, right? So let me go ahead and copy this here. So this would be our x sub I. Okay, so this is going to look like this. The notation would be the sum of each of those terms. And then we had 6 terms, so that's going to be 1 over 6. Obviously, we're looking for the average here. And this is from I equal to 1 to 6 terms. Okay, so this is how we would represent the previous example. So let's go ahead and take a look at the next example and see how we would utilize this. Okay, so as we mentioned, this is going to utilize that previous example. We're going to use the information, from the previous example to represent that. Okay, so essentially what I've done is written what I just wrote. Okay, we're going to take this again, take the sum from I equal to 1 to 6, and this is going to have 1 over 6 terms. This is going to be our average. Okay, and if you were to calculate all of this, add these terms up, we'd find that the average is $2.40. Okay, so the thing to note is that the sigma notation is just another way to represent all of this. Okay, all right, so let's go ahead and move on to example 3. Here, Anthony wants to make a discretionary purchase of a basic laptop computer. He checks the prices of a particular make and model listed by 7 different vendors on a shopping comparison website. He found the following prices: $850, $798, $2,400, $790, $836, $700, and $780. So he calculates the mean to be 1,022. This number doesn't seem to be a good representation of the data, and the question is, how can he find a better representation? Okay, now, first thing to note, 1,022 does not seem like a good representation because we see values of 850, 798, 790, 836, 700. So we would expect the average cost to be closer to some of those numbers. But because we have one price of 2,400, it is skewing these numbers, and that's why we're getting an average of 1,022. Okay, so in this problem, Anthony uses the average to try to determine what would be a good price. However, because it's skewed, another way to do this is to find the median. Okay, and to be able to find the median, we have to list the prices in ascending order. So we're going to have 700, and then 790, and then 798, and then we have 836, 850, and then 2,400. And I think we missed one here. We have a 780 right here. So let's go ahead and move this over. All right, and we have a 780. Okay, so here we have 7 terms. 1, 2, 3, 4, 5, 6, 7. And we want to find the middle term, right? To find the median, it's going to find the middle term. And so the middle term is going to be the 4th term, okay? 798, okay? And so when we look for the median, we see that it's 798, and this is a lot closer to the numbers that we're typically seeing in the various prices, okay? So this is a better way to represent all of these pricing. Okay, so let's go on to example 4. Okay, now example 4 takes into account what we were looking at in the previous example, except the difference here is that Anthony has only found the first 6 laptop prices when he conducted his online research, and here we have to determine the median price. Okay, so here are the 6 numbers. So what we're going to do is the same thing. We're going to rank order this from lowest to highest. So we're going to start with 700, and then 790, and then 798, 836, 850, and then 2,400. Okay, here we've got 6 terms, 1, 2, 3, 4, 5, 6. To find the middle term, we're going to find the 2 terms. So the middle term would technically be right in here. Okay, so what we're going to do is we're going to take the average of these 2 terms to get our median. Okay, so the average would be 798 plus 836 divided by 2, and that works out to 817. Okay, so that is our median price for these 6 pricings. Okay, let's go on to example number 5. So a survey was conducted of 880 college students attending the same university. They were offered a list of 10 different ISPs and were asked to select the one they prefer, okay? So the question is, can a service provider receiving only 89 votes come out on top, okay? So the key word here is can. Is it possible for a service provider receiving only 89 votes to come out on top? Well, how do we figure this out? We have 880 students filling out a survey of 10 different 10 different ISPs, right? So if we divided all 880 by 10, that works out to 88. So all 880 college students could equally give their vote or cast their vote to 10 separate ISPs. However, if one of them ended up having 89 votes, okay, 89 votes, then that means that 8 of the ISPs will have 88 votes potentially, and one will have 87. Okay, and if that is the case, then yes, the one service provider receiving only 89 votes could come out on top. Okay, so here the answer is yes. Okay, let's move on to the next example. Okay, so transportation expenses to and from work are considered essential expenses. Okay, so Victor Lopez would like to reduce this essential expense by biking. This should not be Viking. It would be biking to work rather than taking his car. He found 30 different ads, both online and in print, for the make and model of a bicycle he wants to purchase. He made a list of the prices in ascending order, and here are the 30 different prices. He wants to analyze the prices, but is having trouble because there are so many numbers. How can he organize these prices in a helpful format? Okay, so this is important when you're dealing with a lot of data points, that we represent this data in a way that's easier to digest. Okay, so one way to do this is as follows. We can put together a chart. Okay, so we're going to say the price, and then the next one would be number, or we can call this frequency. Okay, and then we can go ahead and start listing it. So for the price of 250, we have 2 occurrences of those. So we can say 250, 2 occurrences. And then for 275, we have 4 occurrences. So we can say 275, we have 4. And then 280, we have 1 occurrence. 290, 1 occurrence. 310 has 1, 2, 3, 4, 5 occurrences. And then 315 has 1, 2, 3, 4, 5, 6 occurrences. And 320 has 1 occurrence. 325 has 3 occurrences. 330 and 335 both have 1 occurrence. 340 has 1 occurrence, and 350 has 3 occurrences. Okay, so as you can see, when you list the data in this way, we can take a look at this column and see that the majority, or a good portion of the pricing, falls in the 310 to 315 category. Okay, we do have 6 of them falling within the lower price range, and then 3 of them in the high price range. We've got this anomaly at 325, but we have 11. Okay, this is the largest quantity out of the 30 falling in this range. So we would say that the average price should probably be around here. Okay, so this is one way to represent it. Let's take a look at the next example, which is related to this exercise. And in the next example, we're going to find the mean of the bicycle prices from the previous example. Okay, so one of the great things about putting this data in this format is that finding the average is much easier. Okay, so if you can imagine, if we had 3,000 pricing, okay, we would not type in all 3,000 values to find the average. We would put it in some sort of chart like this so that it's a little more condensed. Okay, so if we were to multiply these together, we would say that the total of these would be 250 times 2 is 500. 274 times 4 is 1100. 280 times 1 is 280. 290 times 1 is 290. 310 times 5 is 1,550. And then 315 times 6 is 1,890. 320 times 1 is 320. 325 times 3 is 975. Okay, the rest of these are singular, and then 350 times 3 is 1,050. Okay, so now what we can do is sum all these up, and when we do, we get, let's see here, 8,960, I believe. Okay, and then we're going to divide 8,960 by 30, because there are 30 pricings, and that works out to about, I'm going to say roughly $299. Okay, so if you compare this value to what the data is telling us, we said that it should be about 310 to 315, right in that point, right in that range. Okay, this 299 makes sense because we have 6 data points at the lower value that's pulling the average down a little bit. Okay, so this would be our average of the 30 pricings. Now, as you could see, when you put this in a frequency table like this, adding this up is so much easier than adding all 30 data points. Now, the quicker way, obviously, would be to enter these data points in a spreadsheet, and the spreadsheet could calculate this even faster. But hopefully this methodology makes sense to you. If you ever have to do things manually, this is one way to do it. Okay, hopefully this all made sense to you. If any of this was confusing, or if you need to review this again, please go back to the beginning of the recording and listen to it again. Thank you.